Hello friends, in the last video we have seen that the permutation is the arrangement of the object in a definite order. Taken sum, all are at a time. Also we have seen that the permutation when all objects are distinct, and at the same time we have seen that the permutations when the repetitions is allowed. Now in this video we will see that the permutations in which some objects are identical. In this video I had explained all the examples in a very simple language. I hope that you will understood all the problems whatever that I had explained. Now let us start that the exercise 3.4. In the last video we have seen that all the objects was distinct. Now in this video we see these permutations when some objects are identical. Permutations when some objects are identical are the permutations when all objects are not distinct. In all examples in exercise 3.3 we have seen that all the letters was different. Now in this video we'll see that some objects are identical. Consider the problem when we have to find the number of distinct permutations obtained by rearranging the letters of the word. Let's see this. The first is root, second is India, third is mathematics. Now in the previous exercise we have seen that some words in which the letters was not repeated, but here the letters are repeated, that is the root. O is repeated, India, I is repeated in the mathematics, A is repeated, T is repeated, M is repeated. Now can we answer the questions? What is the reasoning for the answer if you have any? That is how to find the permutations for the above letters and it requires this theorem. That is how to find the permutations of that type of the word. The number of permutations of n objects where P objects are of one kind, means they are similar. Q are of the other kind, and the R and the rest, if any, are of different. That is, it is nothing but the n factorial upon p factorial into q factorial. What is meaning of this? If you have the n objects, and in that n objects, p are identical, q are identical, and rest are the different, then how we can arrange them? We can arrange them like this. That is the n factorial upon p factorial into q factorial. Now, next. Can we prove this result? What is the reason? Reasoning for each step for this. What is the reasoning for each steps? Do you think as follows? This result can be modified to the case where out of n object, suppose if we have the n object, then out of the n objects we have p are of the one kind, q are of the other kind, r are of the third kind, and the rest, if any, are of different kind, then the number of distinct permutations is given by n factorial upon p factorial into q factorial into r factorial. Means what? It's very simple. Now I will explain here. That is, if you have the n objects, and out of the n objects, p are similar, q are also similar, r are also similar, and some are the rest. Then what are their permutations? Their permutations can be written as n factorial upon p factorial into q factorial into r factorial. Suppose there are the n objects, and out of the n objects, that is, there are the some similar objects. For example, q objects are similar. Then it is written as n factorial upon p factorial. If p and q are similar, then it is written as n factorial upon p factorial into q factorial. If p, q, r are the similar number of the similar objects, then it is written as n factorial upon p factorial into q factorial into r factorial, and in this way. Therefore, you have to remember only this formula. Now we'll start the exercise. .4 find the number of permutations of the letters in each of the following words. That is the first, Divya. Now all the letters are the different. How many letters are there? 5 letters are there. That is n is equals to 5. Therefore, their permutations is only n factorial. All are different. Therefore, the number of, now this question is easy. That is the number of letters in the word Divya can be arranged. That is 5p 5 factorial. That is a 5 factorial. That is a 5 into 4 into 3 into 2 into 1. Not a single letter is repeated. Therefore, it is written as 5p 5 factorial. Now see this. This is a second example. What is here? That is a Shantaram. Here, all the letters are not distinct here. The total letters we will count here are 9. Now here A is repeated 3 times. Therefore, also we have seen the formula. The number of distinct permutations of the letter is equals to 9p9 or 9 factorial upon 3 factorial. Means A is repeated 3 times, therefore we write to the denominator 3 factorial. That is a 9 into 8 into 7, 6, 5, 4 into 3 factorial. Now these 3 factorial get cancelled. If again there are some repeating letters, then we will write again multiplied to the by 3. In this way only one letter is repeated and it is repeated to the 3 times, and we calculate this. Now the next is represent. Now see this, in this word what letters are repeated? R is repeated, E is repeated. That is the total letters. First find out the total letters of that word. There are 9. E is repeated 3 times. That is a E is repeated 3 times, therefore it is written P is equals to 3. Now again R is also repeated and it is denoted by Q. That is Q is equals to 2. Now here total number of the words is 9, n is equals to 9, p is equals to 3, that is e is repeated thrice, r is repeated, that is q is equals to 2. Therefore the number of distinct permutations of letters, that is n factorial upon p factorial into q factorial, that is the 9 factorial upon 3 factorial into 2 factorial. Therefore up to the 3 factorial and 3 factorial into these two get cancelled. Therefore you can perform this type of the multiplication. That is a 30,240. Now next, combine. Now in this word, number of letter is repeated. Is 0. That is no repetitions is there. No repetition is there. In this word, the no letter is repeated. Therefore, the number of distinct permutations of letters 7p7 is equals to 7 factorial, and that is normal calculation. That is 5040. Next, that is a Bala Bharati. Now again here the total number of letters, that is equals to 10. B is repeated, that is it is treated as 2. A is repeated, that is a Q is equals to 2. Q is equals to 3. The number of distinct permutations of letters that is equals to 10 factorial, and which letters are repeated, 10 factorial upon 2 factorial into 3 factorial, and again we can have the calculation. Therefore it's next, you have two identical books on English, three identical books on Hindi, and four identical books on mathematics, find the number of distinct ways of arranging them on a shelf. Now see this here. Now the total number of books, that is equals to 2 plus 3 plus 4, that is equals to 9. N is equals to 9. Therefore, English books is equals to, that is the P is equals to number of English books. P is equals to 2. Next, number of books on Hindi. That is R is equals to 3. And the number of books on mathematics, Q is equals to 4. Therefore, the number of distinct permutations is equals of the books is equals to, that is n factorial upon p factorial into r factorial into q factorial. 9 factorial, 2 factorial, 3 factorial into 4 factorial. Now 9 into 8 into 7 into 6, 5 into 4 factorial. And this is normal multiplication, that is a 2 into 1, 3 into 2 into 1, and 4 factorial get cancelled. Therefore, that is 1260 multiplication. These problems are dealing only when the objects are identical. Therefore, the required arrangement of the books is 1260. Now the question number is tossed 8 times. In how many ways can we obtain 4 heads and 4 tails? At least 6 heads. A coin is tossed 8 times. So, the number of possible tiles is n is equals to 8. Now what will be the head or the tail? Therefore, first is here P is equals to 4 heads and Q is equals to also tails. Therefore, the number of ways is equals to n factorial upon p factorial into q factorial, in which we can obtain 4 heads and 4 tails. That is equals to n factorial into n factorial upon p factorial into q factorial. You can have calculations. That is 8 factorial into 6 into 5 into 4 factorial. It is a 4 factorial into 4 into 3 into 2 into 1. These cancel. That is equals to 70 ways. Now the next is, therefore, the answer. The number of ways in which we can obtain 4 heads and 4 tails is 70 ways. Next is at least that is more than 6 heads. We will accept it. For n is equals to 8, at least 6 heads means 6 heads or 7 head or 8 heads. When that is here, we will write here. The number of ways, that is n is equals to 8, p is equals to 6, q is equals to 2, at least 6 state. That is when p is equals to 6, that is a 6 head, then q, that is a 2 will be the tail. Therefore, for the first case, then you will have n factorial upon p factorial into q factorial, that is 8 factorial upon 6 factorial into 2 factorial. Now again, when n is equals to 8, at this way at least a 6, that is we will require, we can take also the 7 head, at that time tail will be the 1, and therefore the n factorial upon p factorial into q factorial, that is 8 factorial upon 7 factorial into 1 factorial, and the last one, the n is equals to 8, p is equals to also 8 and q is equals to 0. That is at least 6 heads, therefore we can write like this. Then the number of ways is equals to n factorial upon p factorial into q factorial, that is 8 factorial upon 8 factorial into 0 factorial, and that is equals to 1. Now we'll add all these 3 conditions. Therefore, the number of ways at which at least 6 heads, 8 factorial of 6 factorial into 2 factorial, plus 8 upon 7 factorial into 1 factorial, and last is 8 factorial upon 8 factorial into 0 factorial. 0 factorial is 1. Therefore, we can calculate like this. It's a simple calculation. So 28 plus 8 plus 1, that is equals to 37. Now next, therefore the answer, the number of ways in which we can obtain at least 6 8s is equals. Next problem, problem number 4. A bag has 5 red, 4 blue and 4 green marbles. If all are drawn one by one and their colors are recorded, how many different arrangement can be found? Now here the total number of marbles, that is a 5 plus 4 plus 4, that is equals to. Next, the green marble is not there, that is 5 plus 4 plus 4, that is equals to 13. Now here P, that is a red marble, that is equals to 5. Q, blue marble, that is equals to 4. And last is green marble, that is equals to 4. Therefore, the number of different arrangements of marbles is equals to n factorial upon p factorial into q factorial into r factorial, that is 13 factorial upon 5 factorial into 4 factorial into 4 factorial, that is equals to 13 factorial upon 5 factorial into 4 factorial into 4 factorial, that is equals to. Therefore, the number of different arrangement is equals to 13 factorial into 5 factorial into 4 factorial into 4 factorial. Now the question number 5. Find the number of ways of arranging the letters of the word mathematics, mathematical. Find the number of ways of arranging the letters of the word mathematical. How many of these arrangement have all vowels together? Now, in the word mathematical, not mathematics, it is a mathematical. Therefore, the total number of letters n is equals to n is equals to 12. M is repeated, that is P is equals to 2. Now A is repeated 3 times, R is equals to 3. Next T is repeated, that is S is equals to 2. Therefore, the number of ways of arranging the letters of the word mathematical is equals to n factorial upon p factorial into r factorial into s factorial. That is a 12 factorial upon 2 factorial, 3 factorial into 2 factorial. Now, when all vowels are together, now we'll see how many vowels are there. That is in mathematical. That is vowels are A, E, again A is repeated, I, A, okay. How many vowels are there? That is 5 vowels. Therefore, here the total vowels, that is n is equals to 5. A is repeated thrice. Therefore, the vowels can be arranged. Therefore, the number of arrangement of vowels is equals to n factorial upon 3 factorial, that is 5 factorial upon 3 factorial, and that is equals to 5 factorial upon 3 factorial. Now all these vowels taken as a single unit. All these vowels together, that is a 5 factorial upon 3 factorial. This is treated as one unit, and the remaining, now the remaining what are the remaining? M, T, H, M, T, C, L. Now here T is repeated and M is also repeated. There are the 7 1. Therefore total N is equals to 7. And what are that vowels? It is treated as 1 here. That is a group of the vowel here treated as 1. And this total are the 7. Therefore, but here again, MT, HMTCL and the OL, that is one unit. Again here, that is M is repeated twice, T is repeated twice, total is 7, 7 plus 8, therefore that is equals to N. That is M is treated as P and next T is treated as T is treated as Q. Therefore, the arrangement of letters when all the vowels are together, that is equals to all the vowels are together, that is n factorial upon p factorial into q factorial, that is 8 factorial upon 2 factorial into 2 factorial. Now the total number of arrangement of the letters in the word mathematical is equals to 8 factorial upon 2 factorial into 2 factorial into the vowels arrangement, that is a 5 factorial upon 3 factorial. Therefore, from 1 and 2, this is. Therefore, it is 8 factorial into 5 factorial, 2 factorial into 2 factorial into 3 factorial. In this way, I had completed this up to the question number 5. And I will see in the next video. Till then, goodbye. In this way, we have completed the question number 1 to 5. I hope that you will have understood all the questions, whatever that I had explained. Now we'll see in the next video for the remaining problems. Till then, goodbye.